I'm Kusnathi Ndlovu, and this is TCS Plus, brought to you today by Vox. Access to stable, reliable, high-speed internet is crucial to participating in the modern economy. Fiber connectivity offers the highest speeds and reliability. Unfortunately, however, fiber penetration rates remain relatively low in South Africa, leaving many would-be customers wanting. Vox recently launched Kiwi, a wireless connectivity solution promising a fibre-like experience with speeds of up to 200 megabits per second. Here to talk about this new product is Theo van Zyl. He is the head of wireless at Vox. Theo, hello and welcome to the show.
Yeah, no, thank you. Thank you for inviting us here and being here today.
It's only a pleasure. It's only a pleasure. Theo, before we talk about Kiwi and the technology behind it, could you tell us about yourself and your history at Vox?
Yeah, so my history at Vox, I haven't been that long at Vox. I've now 4 years. Started in wireless, so my portfolio entails satellite communications, microwave communications, LTE, 5G, the mobile APN services, and because wireless is nothing if you don't have Wi-Fi, so I have Wi-Fi in my portfolio as well, and everybody needs Wi-Fi, so that's basically the portfolio that I look after. History in the industry, been in the industry more than 30 years in telecoms, so I have quite a history in the industry.
Yes.
So yeah, I love telecommunications, so
Yes.
that's what it's all about.
Yeah. Okay.
So I love the Vox culture and environment that we work in. Things happen fast. We get things done. We take new products to market. So a very exciting environment to be in all the time. Yeah.
Talking about bringing new products to market, you've just come out with a new wireless product. Can you just tell me about the rationale behind bringing Kiwi to market?
Yeah, no, that's actually a very interesting aspect. I think we've realized that traditional microwave is actually quite expensive, and to enter into the residential market, they really can't afford it. And the wireless services that's out in the residential market, because a lot of them use, you can say unlicensed band as well, there's a lot of so customers don't get high speeds and good reliability sometimes. Then the other aspect is, fiber is not everywhere. So in some rural towns, there's no fiber. Even in your suburb, there's maybe multi-dwelling units which they haven't trenched and put fiber in. So even in very well-established fiber areas, there's pockets that people don't have fiber. So it's about giving good connections, good connectivity to everybody in a non-fiber area. So that means it's targeting customers that are not on fiber, basically.
All right. And so how do most people who are not on fiber would choose a 4G or 5G connection. What benefits does Kiwi have above those options?
Quite substantial benefits. So if you look at your normal LTE or 5G service, usually comes with a fair usage policy. So they'll block you at 1 terabyte or 2 terabyte. That's the packages out in the market, or even lower sometimes. They'll throttle your speed. With Kiwi, the speed profile that you take has got no fair usage policy on. It's not throttled, so it's open to use. You can download basically as much as you want to. There's no limitation to the amount of data that you can use on it.
But how do you manage to make that happen?
Because it's a fiber-like service, so it's not using the same technology as mobile, which they count in megabytes, because mobile technology is quite expensive to deploy, where this is more a microwave technology. So it's not a mobile, it's a microwave technology, and they have fiber to the towers, so it's basically extension from the fiber at the tower to your home. So if you think of fiber to your home, and you can't get fiber to your home, we actually relay the fiber via a microwave link to your home. And that's actually how we do it.
Okay.
Very similar to what fiber is used. Even the triple PoE session over your wireless technology is the same as your fiber triple PoE session. So it's very, very similar.
All right.
That way.
So one of the benefits of fiber, though, is that when weather changes, fiber remains consistent most of the time. And even in power outages, actually, if you can power your ONT, you still have fiber. Does Kiwi give me that kind of power as well?
Yes, it does, actually. So if you have, let's start with the weather. So if you have rain, because a lot of people talk about rain fade on wireless technologies and then they get a bad experience. We've tested this technology in severe weather and it actually delivers all the time. So you don't get any interference there. I won't say that if a hardy-dar flies past your antenna at 1 meter that you're not going to get a drop and a connection again, because I mean that is unfortunate with microwave. If something flies close by or interferes or you put something over it, then obviously you're going to obstruct it. But weather conditions doesn't interfere with it, and power outages also doesn't, because the high sites have power backup and can sustain the load shedding and the outages that we have in South Africa. So you should have an always on connection as long as you've got power at home, obviously. So if you don't have power at home to power the panel and the router, then you're going to have a problem.
All right, and so what speeds can customers expect from the service?
So we sell a 50 meg and 100 meg speed, and then we have the option to upgrade to 200 megabits per second. And people ask now, why don't you just sell 200 meg? We want to ensure customers actually get 200 meg. So with the 1500, I know for sure we can provide that. But when it comes to 200, we need to make sure that the signal quality, the alignment score of the technology, all those things are in place and the right levels that we can actually give him 200 or very close to 200 megabits per second. So not everybody's going to get always 200 megabits per second.
Okay. Why is that? Well,
it's distance to the tower. So basically, if you're too far from the high site, then you may not get the 200 megabits per second. So let's say you at 15 kilometers or further, you're not going to get the 200. Then we're going to say, no, it's not possible. But if you're closer, within a 5 kilometer range or so, then you should be able to get your 200 megabits per second. And that's how we determine it. So we look at the score, what we call the alignment score, and the path loss on the technology to determine if you're going to get your 200 meg or not. And we can't know it up front. So we'll only know it when it's installed to say, oh, you're good, you can upgrade to 200 now. But we rather play safe. And then then you can actually go to 200. I don't want to overpromise and then the customer doesn't get the 200 meg.
Understood. So I'm hearing you. You're promising me good speeds, you're promising me reliability, but there are some gamers and maybe some high-frequency traders watching the show. What about latency?
So latency is not as great as fiber. So, fiber you'll get 5 milliseconds, 6 milliseconds, or even better. Yeah, you're looking at probably around 20 milliseconds. So I always call them the three amigos. So it's latency, which is what you measure, which I think averages around 20 milliseconds you should get. Then your packet loss is also very minimal on this. So you shouldn't get a high percentage of packet loss. And then the other thing is jitter. So a lot of people forget about the jitter aspect. So jitter is basically if you get packets coming through and the one packet comes through at 20 milliseconds, the other packet comes through at 30 milliseconds. That means your jitter is actually then 10 milliseconds. That's the difference between the two pings coming through. So ultimately, you don't want that when you're a gamer, because that's going to mess up your game for you. So you want a consistent ping rate, and this is what this technology delivers. So your jitter is also very low when it comes to this. And it's the nature of the microwave technology being used to ensure that you actually get a good ping rate or latency when you do this. But it's not as great as fiber. But it's bearable. It's better than LTE.
Yes.
But it's not as good as fiber.
Okay. So a great option if you don't have fiber available.
Great option.
All right. So but let's talk about the technology that makes this possible now. How is it that you're able to get consistent ping rates and ensure that jitter is low, etc.?
So it's all in the technology. So the technology has got multiple antennas in the radios, and then every antenna transmits a signal. Then they make use of what they call beamforming technology, and these how can I say, radios then transmit, and some of the signals are refracted, some of the signals are reflected, but at the end, at the receiving side, it actually put all those signals together again. So it takes all the good signals, put them together, and that's what you receive. So even if you lose half of them, you're still okay because they are received on the other side and they receive. So it takes a chance of finding the best path. And if anything happens, some of the signals it won't receive, but it does receive, it puts together again, and then you get it on your side. But it happens at such a speed that your latency is actually very low. So it's fibre-like. And remember, you have fibre to the tower, so already you've got good latency. So it's just the last mile to your home that you have this wireless technology then.
All right. And then what spectrum are you using now to propagate these signals?
We use 5.8 gigahertz, so it's in the unlicensed spectrum that's being used. Yeah. So yes, it is prone to interference from other signals, especially in the metros and so forth. However, your 5.8 is not as prone to like technologies like 2.4. 2.4 you would know is prone to a lot of interference. Where 5.8 is less. However, there is interference. But once again, because of the beamforming technology, because of the MIMO antennas that they use and so forth, it actually avoids interference. So if there is interference, it just doesn't use those packets it uses other packets that follow the different route that weren't interfered. So that's how they avoid the interference on the tech.
All right. So tell me about the installation and what kind of hardware then is involved in getting it.
So the installation, yes, it does require wires, even if it's wireless.
Yes.
You have a little flat panel antenna on the roof. So it's probably around less than 30 centimeter by 30 centimeter panel. Little flat panel that comes on a little aluminium bracket that needs to be put on the side of your home, on your roof side or something like that. And then from there we run a LAN cable into your home where you want your connection to be. So there we then put a router on, and then the panel on your roof is actually powered by a power over Ethernet adapter. So and then the router then is obviously that provides your Wi-Fi and your internet connection and so forth. So it's actually a less intrusive type of installation. So you don't need any drop wires or underground or anything coming to your home. And the installation usually takes 2 to 3 hours and it's done.
Oh, wow. Excellent. So let's talk about pricing. Which customers are you aiming at, and then how much is the service?
So we aim this product specifically at residential customers. So it's aimed and it's priced for residential, and we try to cut back a lot on cost and optimize as far as possible to make it affordable. I can't get it as affordable as fiber, but it's very close. So a 50 meg will cost you $849 per month. 100 meg will be $1039, and a 200 meg is $1249. So if you compare a fiber, you probably get fiber cheaper, than on a 50 meg than $849. But wireless technology is expensive. It's not as cost effective as fiber, unfortunately. Then the installation is $999, which I think is not that bad, because if you think of the LAN cable, the antenna, the drilling and everything that you do, and the time of technician, I think it's a quite an affordable price to pay for an installation to take place. If you think of a DSTV type of installation, or satellite dish or any of those, then that's basically very similar type of installation. It's a cable going in, a dish on the roof, a bracket. Very similar type of installation that takes place.
And are customers able to check availability on their own before calling you?
Yes, they can go onto the website and they can go to the Vox website under fiber and wireless and go to home options, and then you'll find Kiwi home wireless there, and then you can pick your option, check if you've got coverage there and submit your order online, or if you have an account representative that you want to engage with, you can do that as well.
Okay. Theo, you've said some very nice things, but I still can't get over the name. You've called it Kiwi, and we're not in New Zealand, so I'm going to need an explanation.
So yes, Kiwi is a very interesting point. So we sat in the office one day and we said, what do we call this new product? It must be, you must relate to it, and we actually thought of the kiwi fruit, because if you cut open a kiwi fruit, it looks like a wireless signal that's dispersing in multiple directions. And we thought, well, this is such a great analogy. Let's create the kiwi fruit, and create like a mascot around the kiwi fruit.
Yes.
By the way, the rugby, it's no offense to the Springboks here, but the kiwi that's used by New Zealand is actually a bird.
Yes.
So there's no relation between that. But we chose the fruit, and I actually see a lot of companies using fruit, as a mascot these days in their tech. So we thought such a great idea using the kiwi, but it does represent a wireless signal if you cut it open.
Okay. I'm relieved. Theo, thank you so much for your time and your insights.
Yeah, thank you, Nati. It was very nice chatting to you, and thank you for the opportunity.
Awesome. Do take care. That is Theo van Zyl. He is the head of wireless at Vox, and this is TCS Plus.